Hi developers! One of the things I love about working in industrial automation compared to when I was working with traditional software development is that I get to work close to hardware. Getting to write software that uses and controls a vast spectrum of sensors and actuators can be a lot of fun. One of the opportunities to see all the new technology and toys are industrial automation fairs like Hanover and SPS Messe. I remember that I was at one of these fairs a few years ago and I saw a huge crowd of people around something. That something was Beckhoff's XPlanar. XPlanar is Beckhoff's transport system based on magnetic levitation. When I saw it the first time, I was in love. I mean, it's magnets. Beckhoff's XDS is great and everything, but XPlanar is just a level above. I could just stare and look at the movers floating around. I felt like a kid again, being in awe and wonder. XPlanar is the physical form of everything I love about industrial automation. It's a mixture of hardware, software, and a little bit of magic, all blended together. After that fair, XPlanar has been stuck in my brain, and I've always hoped that I would get the opportunity to work with it. Ever since, I've always found myself visiting the XPlanar demos at the Beckhoff's booths and just stared at the movers. A project to use them never showed up, and I moved on. One day I saw an ad from Beckhoff for XPlanar on LinkedIn, and with a little bit of hope I wrote that I think that Beckhoff should write a simulator for us that still want to learn how to program XPlanar, but that don't have the funds nor the space for a whole physical system. To my surprise, an employee from Beckhoff responded that it's already possible to do using TwinCAT 3. Not only that, he offered me a demonstration of how to do that. This video is made in collaboration with Isaac, the guy that made my inner child very happy. Isaac was very kind and agreed to record the session so that I can share it with you. But first I want to thank all my YouTube members and patrons for supporting this channel. By supporting me as an YouTube member or patron, you are directly helping me to create content for this channel. Also, if you haven't already, then please hit that like button and subscribe to this channel. Now it's time to buckle up. We're about to see some magic happen. I'll let Isaac present himself. So with me today I have Isaac Spear from Beckhoff. Thank you very much.
Yeah, glad to be here. This is awesome. What video are we? Jacob, how many courses have you done so far?
Well, I've only done one course actually, that's about TwinCAT, but I'm already on video 14 or 15 now. Although this is outside of the course, I should say.
That's awesome.
So I'm really happy that you're here.
This is going to be fun.
Yeah, can you tell me a little bit about yourself and your background a little bit?
Yeah, absolutely. So I've been at Beckhoff for 3 years, about maybe a little more. Came from oil and gas and am super excited. Been using Beckhoff for about 8 years now, and it's just been an incredibly fun experience. Beckhoff is definitely pushing the limits of what we know, what's physically possible, and this product is definitely no exception. So it's really fun to be part of just the literally bleeding edge, the cutting edge technology, and not just for automation. This is just, you know, what we know today and what we're capable of in the physical world today. So really fun to get to play with this product. And the coolest part probably is just the team that has developed this. These guys in Germany are just absolutely incredible, just super cool to work with. And it's really what's been fun is as we work through these different applications with this product is we get to really partner with the customer. And so as opposed to, you know, maybe a more simple product where you might say, hey, Mr. Customer, you know, excited for you to enjoy this, you know, you sell it to them and they just go off running. This is very different. And we have literally worked, you know, on a daily basis with product development even to really dial in this product and make sure that it really fits the customer's application and that, you know, we learn from the customer learns from what we can share. And it really is a fun product to be part of, a fun team to be part of. So happy to be part of this session as well, and really excited to show you a little bit about XPlanar.
Yeah, so thank you very much. I should just note that something. Yes, the developers are very, very, very important. I agree to, and equally important is this great support that, at least from my experience, when I've been working with Beckhoff, I've been working with them for quite some time now, and I've always received first-class support. And this is just actually the reason we even talk is quite funny, because I saw an ad on XPlanar on LinkedIn, or someone wrote about it, and then I just wrote there, like, it would be so awesome if I could try this at, like here at in my home, on my desktop computer, and not having, if I can't afford the hardware, or if it's just too big and I can't, run it anywhere, it would be nice to run it at home. And I just wrote, that would be really good if you could make a simulator for it. And then you wrote in the same thread, and like, hey Jacob, I can show all of this to you. It's already possible. And this just shows actually how the atmosphere of the Beckhoff support, I would say, it's the support and the application engineers and everything. I really like the community and atmosphere. So I really, really appreciate it, and I don't take it for granted that you're gonna show this to me today.
Absolutely, yes. We'll get going, and Jacob, I am excited for you to continue this material, and so hopefully this will just start a bunch of other sessions that will focus on specific portions of this technology and hopefully help folks jump into this stuff and recognize that it is not nearly as intimidating as it might look. I think we'll talk about some, very technical concepts today, but the cool part of this product is it's all wrapped together in some very manageable pieces. And so within those individual pieces, it's really not very complicated to get your application built into this product. So yeah, let's rock and roll.
Yeah, great.
Okay, so Jacob, what I was thinking was to start with just a few fundamental concepts and just kind of introduce the product in general. And that way, when we jump into our little live session here, I think some of these terms will make a little bit more sense. So part of what Beckhoff does is we have such cool graphics and illustrations. And so looking at this main graphic here, I'm sure that most people that are watching this will probably have seen this product if it's at a trade show or maybe on some of our other videos or marketing materials. So we are talking about 6 degrees of freedom within each one of these movers. So some basic terminology here. You've got these stationary tiles that would be on like a machine bed or something. And then you've got these movers, these square movers, and then they don't have to be square. We can do some rectangular. I think we're even working on some circular and other shapes. And these movers then are passive. They have an array of magnets underneath them that are organized in what's called a Halbach array, which is known for its magnetic force in one direction. And within this Halbach array, the coils, then inside the tile, there's a bunch of coils in each one of these tiles here. You can see these tiles are square and they're modular. And so these all connect together and then create what would be like the machine bed. And these tiles then are what we actually control in software that then will indirectly then make the mover move in all 6 degrees of freedom. So we're talking about left, right, up, down, Z, up, down, forward, backward, and then we can tilt, we can roll. So can't really make a roll with your mouse. And then of course rotate about the Z axis. And so it's just a super versatile platform, and you can recognize that where there typically would have to be, a bunch of ancillary or supporting axes for a very specific, for a specific application, maybe all of those axes, or maybe all but maybe one axis could go away, and then all of that motion is then consumed with XPlanar, and each mover then would do the all of the motion specific. So XPlanar terminology. This is definitely a word salad. We've got some different libraries: the planar motion library, the physics library, XPlanar standard. Don't be intimidated by this. We're going to go through the majority of it today. And if there is good feedback on this video, maybe we encourage Jacob to do another more advanced session, maybe a part 2, but we'll see how this goes. So within XPlanar, we're going to talk about a few portions. So the XPlanar configurator, which we will be in today. There's an XPlanar driver, and we'll talk about where that is and how you get it. NC3, This is our motion controller that is in software. XPlanar Motion is a library that we'll use today. XPlanar Utility is a super cool and underutilized library, but very, very powerful. And then we'll get to later on today, or in part 2, the XPlanar Standard library, and we'll get into some example projects. So
there's quite a lot of quite few new libraries for XPlanar that have been developed specifically for XPlanar.
Yes, there are some new libraries developed for XPlanar. Absolutely. We will start with 3 basic libraries, but then you can add. I think if I added all of them, I think we'd be around. It would be maybe 5 new libraries. Yeah, okay. But yes, we've got physics, XPlanar Motion. We've got XPlanar Standard, XPlanar Utility. Actually, that might be it. That might just be 4. So, and then of course all of the normal TwinCAT 3 libraries that will go along with it.
Yep.
So, a blank project. If you guys have watched this, if you're watching this session, then you probably are familiar with what this screen looks like. And so we're going to start with XPlanar in no different. One of the things that I am very passionate about is the ability to develop both hardware and software in parallel. And Beckhoff has some incredibly cool tools to do that. So I think traditionally in the automation world, what we will do is, it goes to the mechanical engineers and they build out everything. And then it goes to fab. And then fab comes back, and then maybe a controls guy or an electrical engineer will look at, and they'll kind of, maybe speckle some sensors on it. Hey, I want this, I want that. And then they'll install everything physically, they'll assemble everything is a better word. And then the software guys get the opportunity to start building their application. And then of course it's like, hey, let's go. This machine is done. This machine is ready to go. Why am I waiting on software? And then the software guys are super rushed, and they have a very little opportunity to optimize or to really think through, the way that this machine would be most suited to run. And with Beckhoff and TwinCAT 3, a lot of what the resources on alltwincat.com go through is let's make that a parallel solution. So instead of, having that very linear solution to building a machine, or should I say to commissioning a machine, you can start software at the same time that you start the mechanical design. And so XPlanar is no different. And so we can take a concept. We decide, hey, look, XPlanar is going to be a good fit for this application. And we can send it off to the mechanical guys to start working on the machine bed, start working on maybe, different types of tooling for the movers, and then the things that support that application. And then we can jump right into code. And so that's what we're going to be doing today. I have no extra hardware than just a laptop and my mouse. And we'll run a full simulated XPlanar on the screen. We'll get to see it all move. And with a very small amount of time, maybe 2 clicks, we would have a little bit more linking. So maybe a dozen clicks, we'd be able to take the simulation code and actually make it run on real hardware. So a really cool opportunity to develop in parallel what would be a very challenging process otherwise. So
you're not going to use a PLC or anything. You're running everything from your desktop or laptop computer.
That's right. Yep. Typical Beckhoff MO is we can just operate with trial licenses that are available. Unlimited refreshes, and everything is going to be downloadable off of the website, all available to all viewers. And we're just going to install this stuff on our laptop.
So by the way, I'm gonna mention I will put in the video description below. I will put links to all the stuff that you need to download to actually run XPlanar.
Beautiful, excellent. Yep, excellent. So with this project, we'll start out with a blank TwinCAT solution, and you will recognize the Solution Explorer looks very similar to what we've done in these other sessions. With XPlanar, we're going to add a bunch of different components, and I would guess most of these components are going to be new to our viewers. These are going to be specific to XPlanar. You'll notice that there are some interesting things within XPlanar. If you look here in axes, normally an axis would be what you think of it as one axis. But in XPlanar, we're linking one mover per axis. You could say, well, wait a second here. That's like 6 axes. Well, true. just accept it and we're moving on. So if you'll notice, it's one axis per mover, and that's what NC3 handles for us. So within these portions, some of this you'll be familiar with, the tasks that are associated with the XPlanar project. XPlanar driver handles the communication with the hardware. You've got your hardware configuration, your mapping of your XPlanar hardware, and then, of course, your NC3 and your motion project, your motion controller. So
can I interrupt?
Absolutely.
So for the hardware configuration, how does it look like actually? Is there like an EtherCAT? So you have the EtherCAT master in your laptop or in a PLC, and then is there an EtherCAT slave for every what is it called, tile? Was that the name? Or how does this? Do you connect them together, or how does this work?
Yeah, great question. So XPlanar is very simple in its physical setup. So you're going to have each individual tile, and that tile then has two connections. You've got power to it, and then you've got EtherCAT, and this is actually EtherCAT G. So because of the amount of data and the speed that we need to bring back to the controller, we run through EtherCAT G, and I like to see under 10 tiles daisy chained. So you would have then multiple EtherCAT masters on what would be a big solution. If I had an application where there were 60 tiles and all of those tiles were then distributed across EtherCAT networks, I would like to see each EtherCAT master handling maybe 7, 8, 9 tiles. And so you might have 7 or 8 EtherCAT masters to handle the tiles. So you can see these guys right here, terminal 1, 3, 5, 7, 9. So we'll look at this a little bit more in depth when we go to the live session of this, the live portion of this session. But each one of these tiles then is going to be an EtherCAT slave. We got EtherCAT G between the tiles, and then you can see here as an example, we've got 2 EtherCAT masters here. Here's device 5 and then device 8. And so this device 8 has, I don't know, I'm not going to count them, maybe 8 or 10 tiles, and then device 5 has 3 tiles. So visibly, at least. Within the physical portion of XPlanar, it becomes very simple to set up on a machine. So you've got each tile has your power input, and then it has a EtherCAT input that you can daisy chain, I would say up to 10 tiles each.
Okay, all clear. Thank you very much.
So this was gross. Lots to configure, lots of details. We have an XPlanar configurator, which is excellent, and it will configure all of this automatically with an awesome user interface, and we'll go through building that out today. You'll recognize some of these icons, and you'll recognize the nomenclature of these different packages. So TF5890 is one of the packages that will be linked below for XPlanar. TF5890 is what you will use to integrate XPlanar into TwinCAT. TF5430 is what handles all of the advanced motion behind the scenes. This is what controls those 6 axes that we were talking about. I should say those 6 degrees of freedom that we were talking about previously that are all packaged up into one nice little, we'll call it an axis package. And 5430 is what you will download as well as another package. The XPlanar utility library is super powerful, and you will use this a lot as you actually dive into a real world application. Things like, with diagnostics, or maybe with machine recovery, where you say, hey, or maybe with risk mitigation, you say, hey, there was a power outage, so what's the best way to bring this machine back up? How do I recognize where all of the movers are? Which mover is which? What is the state of all of the movers? Maybe what is the condition of the tiles? Maybe I only want a mover to exert a certain amount of force, maybe in a test or a measurement application where maybe the mover has a device and it's going to push it up against maybe some pins, and maybe you only want it to push a small amount for those pins just to keep a small contact. Things like that where, you want to really fine tune or optimize your application. So that's what XPlanar utility. It also is going to help you color in the lines, instead of overloading your communication to the tiles by, we run at 250 microseconds. The scan must complete every scan must complete in 250 microseconds. So we're running very fast. And in an application where, you maybe unintentionally are checking the temperature of the tile every 250 microseconds, that is obviously not an excellent use of resources. And we probably only need to check the temperature, every 10 seconds or something. And that would probably be a ton anyway. So this gives you, some resources. It helps you color in the lines and utilize, your communication efficiently and not waste it, in goofy tasks.
And this utility library, is that included in any of these two packages, or is that this?
Yes.
Yeah. Okay.
Yes, XPlanar utility will be installed with 58 and 90.
Okay.
So XPlanar standard, we will jump into this in part 2. XPlanar standard is going to be the library that handles a lot of the tasks related to machine function within XPlanar. Think about, for example, all of the movers. Let's say you have 20 movers on a large application. It doesn't make a lot of sense to individually enable mover 1, enable mover 2, enable mover 3, enable mover 4. Sure, you could do that, but it would also be nice if there was just a wrapper that said movers.enable all. That would be a nice thing, and XPlanar standard is what has a lot of those tools for us. So those methods that with regard to track switching, with regard to stations and moving data back and forth between stations, maybe there is an operation at station 1 and station 2 then needs to make a decision based on the feedback from station 1. So that data we could say is passed on the mover, right? You could say that data now is presented to station 1 and then it leaves station 1 as it completes. And then the data is now on the mover and then the mover goes into station 2 and then present station 2 with that data, and then station 2 could make decisions based on the data that it receives from each mover individually. These stations don't have to operate blindly. So a lot of that functionality, a lot of those methods are encapsulated within this XPlanar standard library. So we will jump into that later on. And so you've got the standard library that we talked about, XPlanar utility, we talked about that. NC3 is the motion controller. And then, of course, 5890 is the driver. So within this XPlanar standard, this is kind of what we talked about, where XPlanar standard is going to be the main operation of your machine. XPlanar utility, handles a lot of the ancillary functions. And then from XPlanar, the standard and the utility library, the two supporting packages, 5430 and 5890, will handle the behind the scenes, the under the hood tasks. So within our PLC program, we're only going to be dealing with the XPlanar standard library and occasionally the XPlanar utility library. Today, in part 1, we'll just deal with the planar motion library, but that will take the place of XPlanar standard. Think of XPlanar standard as an extended version of MC planar motion, the planar motion library. So we're going to hang out in the planar motion library, and I think that's an excellent first step to just kind of understand how this crazy machine operates. So this crazy product operates. We talked about safe data access and just keeping, helping your machine operate in the most optimal way possible. One of the coolest parts of XPlanar, we'll actually do this today, is you can rotate in 360 degrees continuously with each mover at any time. So you don't have to have any special hardware. You don't have to have any special software or a special mover. The only requirement for this feature is the mover has to be centered on a quadrant. And so if you'll see here, this is a tile. And within this tile, there are 4 quadrants. So here's a quadrant, here's a quadrant, here's a quadrant, and here's a quadrant, okay? The mover can rotate continuously in 360 degrees at any one of these points. Okay, each one of these tiles can output a maximum force, okay, that is measured in watts. the amount of power that the tile is consuming would be proportional to the force that can be exerted on the mover. So obviously more watts means more force. Each one of these tiles, of course, has a maximum amount of power that they can utilize. Obviously, then, that amount of power determines the amount of force. So if the mover is between two tiles, that means the mover gets to share the maximum power between two tiles. So where you might have 350 watts maximum per tile that could be exerted on a mover in a red dot, you could have up to 700 watts exerted on the mover in a yellow dot, or you could have 4 times the tile's maximum power in all of the green dots. So something to be aware of. The mover can definitely rotate at all of these locations. It just simply means that the payload and the dynamics are decreased slightly.
Is this something I have to think about when I develop? I mean, when I develop my application, is there anything in any of the software you're gonna show me that says that, hey, you can't, if you're gonna rotate on this particular spot, you have these limitations?
Yeah, good question. So really the only thing that's going to limit is going to be the payload and the dynamics. So within software, I don't care. I'm going to go to a point, rotate. In fact, in XPlanar standard, there is a bool that we can look at that says, am I at a rotation point? And it does. And if that is true, then I can go on to rotate. If it's not, then I can make an adjustment, to my next action at that point. So in software, we're not actually going to make any adjustments regardless of whether we're at a red point, a yellow point, or a green point. We're simply just we'll tell the mover to rotate. And then of course, if the payload is too much at say a red point, then, you would see the magnetic field collapse and the mover would just simply sit down on the table. Of course, you would say, it would show you a hardware error. And then you make some adjustments on maybe the mover carries less, or or maybe you move that rotation point over, slightly. This would be 120 millimeters. Maybe you move that over slightly to the yellow point. So that would just be a location change, but ultimately in software, we're going to handle it in a very similar way. The only thing to remember about rotation are the few limitations that you need to observe. So when rotating, you can go as many times as you want. You can go, I believe it's up to 600 RPMs, which is super fast. Remember, the slower you go, the less control we have at certain positions because of the way that the array of magnets is placed on the bottom side of the mover. There are certain positions that the mover is in where they are at their weakest. So if you look at this portion here, this would be where the mover is at its absolute weakest point, where the tile has to work the hardest to keep the mover levitated. And so if the mover just simply sits in this position, obviously the tile is having to work very hard. But if the mover just simply blows by this position, at a higher speed, maybe going from 180, maybe doing a 180-degree turn or a 90-degree turn or something, then this is not nearly as important to take into consideration. So once the mover is finished rotating, it has to be plus or minus 10 degrees from square with the tile. So you can kind of envision a tile around this mover. This edge here needs to be parallel with the edge of the tile, the edge of the mover. And let me say that also a little differently. Any edge of the mover, so we're talking this edge, this edge, this edge, or this edge, needs to be parallel with the edge of the tile. So I think the best way to describe that is just the mover needs to be square with the tile. And by square, we mean plus or minus 10 degrees square with the tile for it to then move on and go to a new point. But with regard to points on the area of tiles, they can be anywhere. So the only limitation of being at the center of a quadrant is just with regard to rotation. But if you only need maybe plus or minus 10 degrees, or you maybe don't need any rotation at all, and then you have the entire area of this product as these tiles make up all of these different layouts, you can go anywhere in that. And we'll look at that a little further as we get into the live portion of this section. So I am finished with that.